A warm welcome to all the viewers. In this session, I am going to explain how you can easily assess measurement model in Onyx SEM via lavaan, that is a package in R. Most of the people have this doubt or this dilemma that running lavaan is quite complex. How will they be able to run lavaan? So I'm going to tell you few simple commands which are quite useful for you to assess the measurement model which is drawn by you in Onyx SEM. Onyx SEM is basically a free software for CB's SEM analysis. It basically helps you to draw in the model and then copy the script generated by this software into the lavaan package of R, wherein you need to put in simple commands for assessing your measurement model. Similarly, you have certain commands to assess your structural model. So first we need to understand how do we assess the model? How do we do the measurement model assessment in case it is a reflective model? That is, all our constructs have reflective indicators, the arrows pointing from the latent variable to the indicators. The first step is we check for factor loadings or the standardized estimates. They should be at least greater than 0.60. If greater than 0.70, that is quite well and good. Second is we check for model fit measures. So there are few model fit measure metrics which we need to check. First is chi-square minimum by degrees of freedom. It should be less than 3 or less than 5 for large sample size models more than 300. RMSEA, root mean square error estimation, that is less than 0.08, tolerable up to 0.10. SRMR less than 0.06, ideal, tolerable up to 0.08. CFI, TLI, NFI, GFI are other metrics which should be greater than 0.90. So this is how we assess the model fit measures. Once our model fit is okay, then we go into check the modification indices if model fit not achieved. Yes, if model fit is not still achieved, then you check the modification indices and you correlate the error terms which are high. Then you check the composite reliability. It should be greater than 0.70. Check the construct validity. Two types of construct validity: convergent validity and discriminant validity. In convergent validity, we check the average variance extracted values. It should be greater than 0.50 for each of our constructs. In discriminant validity, we check it through Fornell-Larker or the latest HTMT method. In HTMT, it should be less than 0.85 for each latent variable. Now let us go to Onyx and see how it is actually done. In the previous video, I told you how you can capture these indicators and put it on the canvas to draw the model. Let me show you once again. So here you go and you say create new model, create empty model. You get this space to draw the model. In this space, you have to draw the model, right? So how you bring in the indicators, I've told you in my previous video also. Select the first indicator, press the shift button and select the last one. Now just drag it. You have the four indicators. These are the error variances. Now I need the latent variable for this. I go to create variable latent. This is the latent variable. Right click, connect it to the indicators. You simply connect it to the indicators, the arrow pointing towards the indicators. Now you fix the parameter, and here you select them all and you free the parameter. Now what you see is the unstandardized estimates. These are the unstandardized estimates, but we want to see the standardized estimates. So I select all of them and then again right click, show standardized estimate. Now friends, what you see, the outside number is unstandardized. The inside within the bracket is standardized. This is the factor loading, standardized factor loading or standardized estimate. And this is outside the round bracket is unstandardized factor loading or unstandardized estimate. Now, this is how you simply draw a model, latent variable in Onyx canvas. Now, for measurement model assessment, what I need to do, I need to capture all of these five like this into my canvas and then co-vary them. Let me show you one more how to co-vary them. so that you understand how to build in the covariance between them. So now I am capturing CA1 to CA4. This is how I have captured them. And then I draw the latent variable, create variable latent. This is the latent variable, and I will connect them just like I did last time. I connect them with the indicators, connect it with the indicators, and I fix the parameter, select them all, free the parameter, and tick on show standardized estimate. Now I have done it. Say for an instance, I had these two latent variables in my study. How to covary them easily? You select, right click, and then add path, add covariance. Now you connect it. Now you see a double headed arrow. This means covariance created. I click on this arrow and free parameter. Now you see I click on show standardized estimate. 0.16 is the covariance and zero point 0.4 is the correlation. So you get these values. Correlation is the standardized value of covariance, right? So this is how you can do it. Now, instead of copying all of them together over here and taking a lot of time, I've already built in this model. Let me show you how it looks like. So I go to Onyx, load model or data. So I already have built this. You see, I open it now. You see, all five are here. 1, 2, 3, 4, and 5. Right? So this is food quality FQ, CA cultural authenticity, SQ service quality, VM value for money, and behavioral intention BI1 to BI4. So in measurement model, you take all independent as well as dependent variables and you co-vary them all. We are interested in looking at the standardized factor loading, which is inside this round bracket, that is 0.73. This value has to be greater than at least 0.6. Though it is recommended, it is good if it's greater than 0.7, but still 0.6 is good enough to take ahead. In case any of the standardized factor loading of the indicator is less than 0.6, you have to think of removing that indicator. But keep in mind that each latent variable should at least have 3 indicators with it for assessing the model. Otherwise, it will be a problem later on for reliability and validity establishment. Now, in this case, as we see, food quality 1, good, 0.73, FQ2 0.9, FQ3 0.85, FQ4 0.59. It's on the verge to 0.6, right? 0.59 on the verge to 0.6. Next, we see value for money. Now, again, we have to standardize them. Show standardized estimates, you see 0.76, 0.81. Then standardize these one. So this is the way I can see the standardized factor loadings. Now the function of Onyx is limited because it is a graphical interface for building the model, teaching the model, understanding the model, and seeing the basic factor loadings on this graphical interface so that you come to know which indicator might create problem later and you think about removing that indicator from the model. All those calculative assessments of measurement model, the detailed assessments, for that we will have to go to R and write a script manually over there, because taking the script from here, the script, although the script generates easily, you go to write option, click show script, lavaan, and the script will be generated. Once you execute this model, the script will be generated. But this script will not run in R quite easily. So you'll face some problems. So I'm going to show you a simple method by which you can put in the commands in R and assess the measurement model with all the results displayed instantly in R. So let us go to R, the lavaan package in R, and see how to go ahead. We are in our R Studio. I've already installed lavaan package. You see here, the first step is installing lavaan package. Install Haven package in case you want to take the SPSS file as input in R. Then install packages SEM tools, structural equation modeling tools. Then install packages readr. After that, you load the library lavaan and load the library sem tools. So I'm going to do that. You see here, I'm going to type library lavaan, press enter. So it says this is lavaan 0.621. It is a free software. Then library, make sure that you have already installed these sem tools, right? So this is SEM tool 0.58. All users of R or SEM are invited to submit functions or ideas for function as it is an open source software. Now, we are going to assess the measurement model. First, we have to load our data. How to load the data? I pick up this command because my data is in CSV format and I paste it in R. You see, I'm telling you quite easy and simple steps to execute the measurement model. In case you don't have access to IBM SPSS MOS, don't worry, you can do the measurement model assessment. You can do the structural model assessment in R quite easily following these commands. So once I write this command in R, I just press enter and it will ask me for the source of the data. You see this window pops up. Where is my data? It's here. This one is the CSV sheet. I click OK. So model data 204 observations of 25 variables. It shows me, right? Next, what I need to do? Next, I need to put this function for assessing the measurement model. Now, what all is there? You see, model x1 variable 1, latent variable 1 consists of 4 indicators fq1 to fq4, latent variable 2, ca1 to ca4, latent variable 3 sq1 to sq4. This is as per the naming given in the CSV data sheet. Here we are not importing any script from lavaan, right? Because that may cause errors. Then value for money 1, 2, 3, 4. Behavioral intention 1, 2, 3, 4. Right? I copy this command and simply put it in R. So I did this, press enter. And next, result CFE model. FIML, full information maximum likelihood. You must select this thing in case you have missing values. Otherwise, you can go with ML as well. FIML stands for full information maximum likelihood, and it is one of the most powerful and modern statistical methods used to handle missing data in SCM and CFA, right? So what I do, I press CFA command over here and press enter. Now nothing is printed. Don't worry, the command got executed, but to see the results, I need to put in one more command, that is summary of the results. I copy it and put it over here. Now friends, just see how many commands did I use. I just opened the library lavaan, which is already installed. I opened the library sem tools, which is already installed. Then I type this command to read my CSV file, load my data. You see data is loaded. Then I run this command. This tells lavaan that what is the structure of my measurement model, how many latent variables are there, and they are formed of how many indicators. I have to write it in this format. These nomenclatures have come from the CSV sheet, how I have named them in my CSV sheet. Next, I press enter and give this command result CFE model and I choose FIML. In case I have missing values, I can go with FIML or I can go with ML if I don't have any missing values. Maximum likelihood, right? The same estimation method which is used in IBM SPSS MOS. Then summary. I type this command and once I put this command, I just need to press enter. You see, the results pop in instantly, and these are the things which you would like to see for assessment of your measurement model. These are the test statistics. That is 360.617. That is the chi-square value. Degrees of freedom 160. P-value of chi-square is 0.000. This has to be greater than 0.05, but this is not an issue because this p-value of chi-square statistic is quite sensitive to the sample size, as we see in IBM SPSS MS as well. Remember, we are running a maximum likelihood estimate over here, assuming that our data exhibits normality. Now in this case, the value which we check is chi-square by degrees of freedom. This is test statistics 160 divided by degrees of freedom. This has to be less than 2.0 or less than 5 in sample sizes which are greater than 300. Now, in our case, it comes out to be about, when you divide 360.617 by 160, 2 point something, right? So, this is okay. We will see the CFI, the TLI, both of which have to be greater than 0.90. In our case, CFI is well above 0.9 and TLI is 0.898. So it is near to 0.9 but not 0.9. Next we see RMSEA, root mean square error of approximation. The value is 0.078. It has to be less than 0.08. That means it is okay. Then we see SRMR, standardized root mean square residual. That has to be less than 0.06. In our case, it is 0.061. Then I have the latent variables and their estimate. This is unstandardized estimate. This is standard error. So once you divide the estimate with standard error, you get the Z value. This Z value has to be greater than plus minus 1.96. In this case, we see all are greater than plus 1.96. This shows that they are significant. They are significant indicators. So this is standardized indicator value, which we saw in standardized factor loadings of the indicators, which we saw in ONYX as well. FQ1.730, FQ2.901. Let us check. See, FQ1.73, FQ2.9, FQ3.85, FQ4.59. So it's same over here, you see. These are the factor loadings, standardized factor loadings. So here you can check that all of them are above 0.6 in our case. So they are well to go. This one is only 0.588, but it can be taken to be 0.6, right? So all our factor loadings is okay. So we go ahead and check the model fit measures, which I told you right now, RMSEA, SRMR. Apart from this, you get the covariances table. These are the latent variables x1, x2, x3, x4, x5. And these are the standardized values, that is correlations they exhibit. So x1 exhibits a correlation of 0.396 with x2. x1 exhibits a correlation of 0.383 with x3. With x4, 0.362. With x5, 0.406. Okay. This is the way you can check the correlations between the latent variables. Let us go and check in ONYX as well. So how to check it in ONYX? You see here. X1. You see here. I just make this standardized. Show standardized. Here you have the covariance value 0.2 between x1 and x5. This is x1 and x5. Covariance is 0.2. Correlation is 0.41. Next we have the intercepts, variances. What else do we need? We need the modification indices. So in case we want to check the modification indices, we can put this command and check them. So these are the modification indices. These are especially used in case the factor loadings, the standardized factor loadings are less than 0.60. So you want to remove an indicator to improve the model fit. You remove an indicator, but still the model fit does not improve. In that case, we look in for modification indices and then we correlate the error terms of a single latent variable. The highest is between BI1 and BI2, 57.844. So in case I covary them, it means that the chi-square will improve by 57.844. The chi-square will improve, that is the value will reduce by 57.844. Next, why this value of 3.84? The value 3.84 is used because it represents the critical cutoff point on a chi-square distribution table for a 95% confidence level. So you have to take this command as it is because we are working on 95% confidence level. Next, we will use this command to check the reliability. This gives McDonald's omega, which is a better estimate than Cronbach alpha. So I'll use this to get the reliability. You see, I got the reliability. So FQ1, 2, 3, 4, 0.852, right? The composite reliability of first latent variable is okay. Second latent variable is okay, 0.851. It has to be above 0.70. Third is okay. Fourth is okay. All are above 0.8. That means we have good reliability of the latent variables. That is what we are assessing in measurement model. The reliability, the validity of our latent variables. Next, we need to check the validity. How to check the validity? First, we'll take the AVE because we are going to assess two types of validity, convergent validity and discriminant validity. For convergent validity, we want the AVE. All of them have to be above 0.5. So in our case, this is okay. X1 0.605, X2 0.619, X3 0.603, X4 is 0.632 and X5 0.598. All are above 0.5. That means convergent validity is established. Now, how to assess the discriminant validity? Fornell-Larker criteria or HTMT criteria. Preferably, we should go with HTMT criteria. So for getting the HTMT, you just copy this command and type here and you'll get the results. Now you see, the values have to be lesser than 0.85. So in this case, you see all values are less than 0.85. That means the discriminant validity is well established. In the next video, I'll show you how you can easily assess the structural model in lavaan package of R. I hope the video was quite informative and useful for you, and you will definitely share it with your friends and faculty colleagues. See you next time with some more informative content. Thanks a lot.